Hi all, I'm Vivek Samu and I'm a postdoctoral research scholar in the Civil Engineering Department at North Carolina State University, and I'm working with Dr. Murthy Gudati and Dr. Shane Underwood. Welcome to my presentation on characterization of pavements through non-destructive surface wave testing. Did you know that United States has the largest road network in the entire world? Needless to say, roads are critical for the transportation of goods and people, and proper maintenance of roads is critical for the country's economy. There are more than 2.6 million miles of paved roads in the United States, and over 94% of them are surfaced with asphalt. These are the black roads that you drive on a daily basis. Over the years, the traffic demand has been consistently growing, and it is estimated that 43% of our roads are in poor or mediocre condition. Thus, it is important to evaluate the current condition of pavements to find the remaining service life of the pavements, and in order to find the best suitable rehabilitation method to increase the service life of the pavements. Thus, the aim is to develop a methodology to evaluate the in-field properties of pavement layers. In order to do this, we're going to be using what are called as non-destructive evaluation techniques. As the name suggests, these techniques are used to evaluate properties of the materials or structures without causing any damage or disruption to their functionality. Specific to our research, we're going to be using a method called as a surface wave method, which are commonly used to evaluate properties of soil layers, which are similar in structure to pavement layers. The idea is pretty simple, and we use a handheld hammer to impact the surface of the pavement, which basically generates a wave that travels in all directions in the pavement. And we record these traveling waves using sensors at specific locations. How we use these recorded signals to get back the pavement layer properties is the crux of the remaining of my presentation. While the idea of the surface wave testing is pretty straightforward, it comes with its own challenges. You need multiple sensors at increasing distance from the impact to be able to reliably and repeatably record the waves that are generated from the impact. Often, this results in bulky and costly equipment, and this procedure is time-consuming. So in order to overcome this, we have adopted a recently developed methodology where we simulate the exact results that we get from multiple sensors by using a single sensor, but moving this impact farther and farther away from the sensor. So in order to establish this, we've assembled a set of equipment that fit inside a backpack and are fully powered through a laptop computer without any external power requirement. And this equipment set is fully portable and significantly reduces the time required for testing. A typical pavement structure consists of asphalt layer and multiple other deeper layers, and the sensor is installed on the top of the asphalt layer, and multiple impacts at increasing distance from the accelerometer are imparted to the top asphalt layer, and the signals are recorded at the accelerometers. Special care is taken in order to preserve the time signature of these waves coming from these multiple impacts. All these impacts, signals are arranged to obtain what is called as a surface trace plot, where we have these waves as a function of time and the distance between the accelerometer and the impact. This is further processed using signal processing techniques such as Fourier transform to obtain the velocity of wave propagation, which is sensitive to the layer properties of the pavement layers. This red curve, which you see in here, the velocity curve, is the key to estimating the layer properties. And the idea behind doing that is to create a computer model that can represent the actual physics of the wave propagation in the pavement layers. And this is done through newly developed modeling techniques that can provide accurate and efficient way to model the pavement layers. So by matching this theoretical curve with the experimentally obtained curve, we can get back the top asphalt layer properties. And we got pretty good results for the pavement thickness and the pavement modulus for the, in comparison, typical properties for pavements in parking structures. So in summary, what we have is a surface wave testing methodology to evaluate the properties of the top asphalt layer. Going forward, we will build on this research to further evaluate the deeper layer property in addition to the top layer properties, and we would continue testing on multiple different pavements with the ultimate goal of developing an efficient methodology that can provide fast and accurate estimates of the pavement properties for engineers to better manage our aging roads. Thank you.